Welcome to Event Coding. In this tutorial, I will demonstrate how to create a REST API using NodeJS with a connection to the Microsoft SQL database. Before we start, we need to install Microsoft SQL Server, SQL Server Management Studio, NodeJS, Visual Studio Code, and Postman. I will show the installation links one by one. For Microsoft SQL Server, we can download the developer version from the Microsoft page. Similar for SQL Server Management Studio. Next, download Node.js. Next, download VS Code. Finally, download Postman. After finishing installations, we will configure the SQL Server. Open SQL Server Management Studio. Create a new database named MyDB and create a table named task. It seems that running the whole script at once does not work. Let's run the statement separately. The table is successfully created. Let's create a new user for accessing the database. I will set my password 123. After setting up the SQL Server, we can dive into creating the REST API. Open VS Code, create a project folder and initialize a Node.js project. The entry point of our API will be app.js. Create the project files and subfolders. We will follow the model view controller pattern, namely MVC. We will create the model named task and the controller named task controller. Task controller will handle all the incoming calls to this API. Create root folder for storing our routing paths. We will create two files inside the aproute.js and index.js. We will use the router object defined in apiroutes.js in our index.js. Meanwhile, the router object defined in index.js will be used in our app.js. dbconfig.js will be used for storing the SQL Server connection details. Let's install the dependencies. We will use CORS Express, HTTP status codes, MS SQL, and NodeMon. Let's add a script named start so that we can use NodeMon to run app.js. We can now create our server using Express. CORS is a mechanism that allows restricted resources on a web page to be requested from another domain outside the domain from which the first resource was served. By using CORS, we can control the accessibility of this API from the other application. For example, a front-end application you will develop in future. These two lines are body parser. Body parser is the NodeJS body parsing middleware. It is responsible for parsing the incoming request bodies in the middleware before you handle it. It's commonly used in web applications built with Express.js to handle form submissions, JSON payloads, and other types of request bodies. We will use it to send post requests for creating tasks. Let's create the task class. We will construct an instance whenever we create an update task. Let's import task models and other dependencies in the controller. We will use the controller to handle different requests stated in routes. We will now write our SQL Server config file. Next, let's create the router object inside index.js used by the app.js. /API will be the subpath for handling our API calls. We will further define the subpaths in api-routes.js file later. For solely /, we just return a JSON object indicating the server is running. Now, let's write the API routes. We will define our server response in controller, so we have to import it here. Let's define the route for reading tasks. By sending get request to /tasks index and respond JSON will be called. We will later define these two functions in controller. It is expected that the full list of tasks will be returned. Now let's create one more route for reading single tasks. For returning single task, we define our route as /tasks with a request parameter named ID. Accessing this route will trigger index 1 and respond JSON in our controller. Now let's define index, respond JSON and index 1 in our controller. We will use SQL request.query and supply the SQL command in this tutorial. If we want to call stored procedure, we can call SQL request.execute and supply the stored procedure name. Store the result as local variable using response.locals. We will get back these variables in respond JSON function, which will be defined later. Don't forget to place next for passing control to the next middleware function. Otherwise, the server will be blocked. If there are any errors, they will be passed to next middleware function. The error would be handled by an error handler. We will define the error handler at the last part of this tutorial. Now, let's focus on respond JSON function. This function will respond a JSON object, which encapsulate HTTP status OK, and the variables stored while fetching. We can now test the route for reading task. I have commented the second routes you do not need to follow. Meanwhile, don't forget to export the router object such that index.js can use it. It seems that the password is expired and SQL connection is unsuccessful. Let's check it in SQL Server Management Studio. Let's change the password and test the API again. I changed my password to 123456. Let's change the dbconfig and test again. We can see that the API is working. The task list is shown in record set under data attribute. Currently, the table consists of no tasks, so it is empty. We can specify showing the record set such that the return JSON object is cleaner. Let's move on creating index1 function. It will return one specific task matching the ID stated in the request parameter. This request.params.id is matching what the user supply as request parameter. We will use SQL request.input for providing input in SQL command. Now, let's also create the create root and the controller actions such that we can test index 1 and create all at once. For creating a task, user need to send a post request to the /tasks root. It will trigger the create function and respond JSON function in controller. Let's create the create root in controller. We will make use of the body from the request for constructing the task object. Use the task object attribute as input values for SQL command. Write the SQL command insert into task using the declared input values. We can now test the routes for reading tasks and creating tasks together. It seems that I haven't saved the route file. Let's save it and test again. We can see that the create route worked as expected. One task have been created. Let's create one more task. We have 2 tasks in the task table now. We can now proceed with the update route. We will use put method for the update request. Similar to reading one record, user have to supply ID as the request parameter. We will use update and respond JSON function in the controller for handling the update. Let's define the update function. Similar with creating object, we will construct a task object for handling update. The attributes of task object are then used for supplying the SQL command. We can now define the SQL update command using the declared input variables. We can now test our update route. First, the route for retrieving all tasks is working fine. We can see the 2 tasks we have added. Now we consider making an update on the task with ID 2. Reminded that the route is /task/id/update. Let's set the new task name new homework, new deadline 202111, new task reps 3 and new file path hw.png. It seems that I forget to save the API root file again. Let's save it and try again. We can see that the update is successful. Let's check the full list of tasks using /tasks. We can see that the task with ID 2 is updated. Now we can proceed with the delete routes. We will use delete method for the delete request. Similar to updating one record, user have to supply ID as the request parameter. We will use delete and respond JSON function in the controller for handling the delete. Let's define delete function in controller. This time, we only have one input for the SQL command, which is the ID provided by user in the request parameter. We can use the delete SQL command for deletion. Now we can test our delete route. Let's delete the task with ID 2. We can see that the delete route worked as expected. Let's get /tasks for confirmation. We can see that tasks with ID 2 disappeared. The final part is about error handling. SQL connection and SQL queries may throw errors. Those errors are caught and carried to the subsequent middleware. So how should we handle the errors? Let's define a middleware named error.json for handling that. This middleware will return a JSON object indicating the error message and the HTTP status. Finally, we need to tell the router to use this middleware. When any errors are being thrown during SQL query, the error handler middleware will be executed and the error JSON would be returned. This is the end of the full tutorial on building REST API that support create, read, update, and delete using Node.js with connection to SQL database. Thank you for watching Ivan Coding.